Hello everyone. Let's look at the daily Leetcode problem 2163 minimum difference in sums after removal of elements. Before starting this problem, let us have a small motivational quote. Perfecting something requires patience, sustained curiosity, and a deep commitment to continuous improvement. It means maintaining the same enthusiasm while asking questions, exploring details, and solving problems, no matter how long it takes. By staying engaged and methodically addressing challenges, you refine your understanding and skills, turning good into great through persistent effort and iterative learning. I specifically wanted to bring this quote because everyone in has a specific interest, but becoming a master's at it or becoming great at it or becoming the kind of profession person that you want to become at it requires continuous effort of perfecting something with patience and the curiosity to learn, and the curiosity and the interest to learn should never die away, right? So yeah, with that being said, let us tackle this hard lead code problem. So let's go through the problem statement given here. You are given an zero index integer array nums containing 3 into n elements. You are allowed to remove any subsequence of elements of exactly size n. Remaining two elements will be divided into two equal parts. First n elements belonging to the first part, uh, and their sum is sum first. Similarly, sum second for the next part. Difference in sums of the first part is denoted as sums first, and sorry for that. So sum first and second. For example, sum first is 3 and sum second is 3. The 2, the difference is 1. Similarly, sum first is 2 and sum second is 3. The difference is minus 1. Return the minimum difference possible between the sums of the two parts of the removal of n elements. So let's understand this better through an example here. So let's say nums is 3, 1, 2. We are allowed to remove one third of the element. So let's say if we remove one element that splits into two equal parts. So let's say if we remove 3, then the element gets 1 and 2, where 1 is the sum first, sum second is 2. This will be minus 1. Similarly, if we remove 1, then we would be left with 3 and 1, which would give us the difference 1, and so on. And the minimum difference is 1, as we saw in this condition. So the same, more or less, the same understanding would uh, be given here as well. The approach to this problem, or the thought process to this problem, would be: so we are required to build three parts. One is n, uh, n into 3 will be the size of the input nums, and we are required to build sums first and second, where sums first, so we need to have this value as minimum as possible and sum second as high as possible, right? So we can do that with a heap, where we can use min and max heap. And the only difference will be removal of the first part. So one third we need to remove, right? So which means we would be left with varying set of arrays, right? And let's say we our only goal will be to take one third sums one first and second, such that at different points, at different indexes, we need to find the difference between first and second, and we can return the min difference. Easier said than done with these three lines, but this is an hard mark problem. So I would the best way to go about solving this problem would be writing code and explaining it. Most of the code implementation lies around how we build this min heap. I am not sure how this goes in other programming language, but I am going to be using JavaScript. So we might need to have a custom method such as build heap method just to build a min heap for left and right parts, and also a right heap such that and the value will be uh, of max value such that we can maximize the right portion of the right portion of the sum. And then with first and second sums calculated at different indexes, then we would be able to calculate the minimum possible difference, and we can return it, since both uh, the first and second sum array will be of same length, right? So I would go to the Leetcode editor and write some code and explain it. So that's the way that we are going to solve this problem. So the first set of functions that we are going to build is with respect to constructing an heap. So we are going to build an heapify method which takes in an array heap and a specific index and size, and returns us an array such that it follows the bin heap property. So we check for conditions such that a specific index has two child elements, such that a left child and a right child exists for the specific index, and it is less than the size of the array. And we are going to also check such that uh, the specific index has a value greater than its left child and the right child. So that's the two conditions that we need to. Okay, so So this condition here says that if the left heap is greater than the child or the right portion of the heap, then we move on to the next child, and we swap the values of the current child with the specific heap index. So that's what we are going to do. So outside the while loop, we also make certain boundary conditions check such that the there are two child elements. If the head element is greater than the left child, then we swap the head index. So that's another thing that we are doing here. So we perform something similar to this operation here. So we okay. So with that being said, we also need a build heap method, which so we are going to be building this heap from the bottom up, and that's where this for loop iterates backwards. And we are going to be using the heapify method, which takes an array, an index I, and also size. Right? And this method is going to be used to build the left and right portions of the heap. So which we are going to do next. I hope you have understood these two functions right here. So this heapify method takes in an array, an index, and a size, and at each index we check if there are two child elements, and also the left child is greater than is less than its parent node for both left and right childs, and we check if the left child is greater than the right child, then we swap it up here, else we have another boundary condition check after this while loop asking if there are two childs for a specific node, else we return. And that's the way we sanitize and we build a min heap, right? So, and this build heap method is the one that calls this heapify method. Okay, so now we are going to start building the left and right portions of the array. Before we do anything further, we are going to split this, or we are going to calculate uh, three parts of the length from the input array nums. And now we are going to build a left heap. And this is going to be a left sum array where we are going to calculate the left sum at each index, maybe shifting to different indexes. So we initialize it with left heap, and we calculate all of the values in the left. We are doing this negation operation here just to make sure the values, since we have built this heapify method such that it operates, or it gives us a min heap. If we negate the value and if we build a min heap, then it would be just like a max heap, right? So similarly here we are calculating all the sum values, and with the negated value we are required to subtract such that minus of minus will become plus, right? And we start off this reduce with 0. Okay, now we calculate at different indexes what is the left sum. We are going to perform the same operation for the right part of the right sum as well. So we are doing this as length minus 1 plus I, right? So this is because we are looking at the array, which is the two-third portions of the array. Like, let's say we divide the array into three equal parts. Here, the length, and for accessing the second two-third part of the array, we are doing it length plus I, such that we are reading everything after the first one-third portion. So that's what we are doing with. So we check if the current value is less than that of left heap of 0, then we replace it with the current value, right? So to the max heap, to the left heap. So we need another function to replace this root, which we are going to build right after this for loop. So so if the current value is less than the left heap of 0, that is, it's a value less than the current heap, then we are replacing it. Similarly, we are not going to replace anything if the current value is greater than the left heap of 0. We are going to simply leave it as it is, calculating this way, and that should complete our left sum portion. And this function, we are also going to implement it now. So I am going to add it here. We just need to replace the specific root node. So this is going to take in few arguments like an array heap size and a new value. And const removed is equals to zero value that we get, and also we reconstruct the heap to keep the heap properties intact. So if you see, the heapify method is being called in two places, one during the construction of a heap and also when we are replacing a specific element or a specific node in a heap. Okay, so now we are going to do the left portion of the heap. Uh, this will be 2 times length and length, so that's what. So we are going to build it, and also we are okay. The right heap is going to be following a property of min heap, and we do not need to negate this value, right? And the nums length 2 times length 2 times length minus I, and this will be 1 2 less than or equal to length, so that should be it. And this again will be greater than right heap. Right heap of 0, and replacement value, if there is current value greater than right heap, then we are going to do it this way. So heap length and similarly right sum. This is going to be right sum. Right sum, right sum, and this is again going to change the signs. Okay, so that should build the right side portion of the heap where this is going to be a typical min heap, right? So once we have this, we are good to calculate the minimum difference that we are looking for to solve this problem. So we initialize it with a max possible value, and then we iterate through the left or the right heap, since both of them will have the same length, and we calculate the difference, and we, for each difference we only take or we only reassign, so this should be lit. Okay, so this would be left sum of I minus right sum of I, right? So always we are taking the minimum of this value, and we are good to return this value, and this should solve our problem. Let us try submitting the solution before we. Okay, left line number 39 is left sum cannot read property dot reduce left heap build heap. Okay, so cannot read property of undefined reading reduce. Okay. Yeah. So okay, so I believe the function name doesn't match. Let me try running it again. Okay, cannot read property of undefined reading reduce solution min difference. Okay, line number 39. Oh, we are still here. Left heap, build heap. I believe this should all be fine. Left some array length. Okay. So I think I found this issue. So we need to be returning an array after this build method. So that's something that I will add it up, and let's see if this reduce method works now that we have an array to perform this reduce operation. Okay, so now we are in a different stack trace where the issue says current is not defined. Okay. Okay, now all of these are matching. Okay, that sounds just about right. Let's see. Okay, so replace root left heap is not defined. Okay, I believe there is a typo. Okay, that should solve that. Let's continue solving the other things. If current is not defined in line number 55. Okay, so I will copy paste this same thing. Okay, so current is greater than right heap. Okay, so current is removed. Okay. Null is not defined. Type long. Okay. Okay, so let me try resubmitting if that really solves the issue. Since we are iterating 1 to the length, similarly here I had a 0. So let's see if that really solves the problem. Okay, so at least we are getting something here. Now all of the issues are solved, but there still seems test case failure where some logic is still not in place. So I have changed the signs of this one here in the left side, while this seems to be not changed. So this is a portion where we are doing a check if the current value in the nums array is greater than that of the right heap right heap value, so that we can replace it to increase the sum in the right heap, such that we increase the maximum difference at the specific index, and we replace the specific right heap element and also with the current node, and also we calculate the new right sum. So that's what we are doing here, and just the signs changes for something that I just identified was a logical issue. Let's try resubmitting this. As you can see, the solution gets submitted. Let me know in the comment section what might be the real world use cases or any practical scenarios where this problem might really be useful. uh, just to repeat what this problem is expecting, there is an array of size 3n, and we are required to remove n set of one third part of the array, and remaining two third is split into two parts, such that some first and some second, and the difference is asked to be minimized, or we need to return the minimum possible difference, right? So yeah, also time complexity of this solution would be O of n, and the heapify operations uh, would be log n. This heapify operation would be at the most log n, right? So it would be n log n, since, and also space complexity would be O of n, as we are required to create two separate arrays for left and right sums. Hope you found this video helpful. Please let me know in the comment section this problem would be how this problem would translate to real world scenarios. Thank you.